Okay, today we want to do the second half of our graphing skills notes. I want to remind you that graphs are important because they let us know how two variables are related. They let us get an equation to make predictions and explain events. Parts of a good graph. Remember, the independent variable is x, the one you change. The dependent variable, the one nature changes, goes on the y. When you write it out, y versus x, and then the conditions that the experiment took place under. Make sure when you set up your scales that the highest value of x at least reaches the halfway point. The highest y value, make sure it's at least higher than halfway up. Graph types, we talked about two of the simpler ones. Linear graph, y equals mx plus b. I want to take a moment to elaborate a little bit on m, the slope. To find the slope, you just pick 2 points on the graph, not data points. The data points may not lie on the graph. They're experimental points. There's error built in. So pick points from your line. Measure the change in x, measure the change in y, and find the slope, change in y over change in x. Next, we have proportional graph. A proportional graph is just like a linear graph, except it goes through the origin. It has no y-intercept. You find the slope the same way. You pick 2 points that are on the line, not data points, and you do change in y over change in x. Okay, here are the new ones, so make sure you draw out this graph. It's called an inverse graph. An inverse graph means that as x gets bigger, y gets lower. Your y values go down as you move to the right. The equation looks like this. Y equals a over x. The a is called your graph constant. Remember that x is not really x, it's whatever variable is on the x-axis. And the y is whatever variable is on the y-axis. Notice it's steep, less steep, really less steep. So it gets less steep as you move to the right. They are all the properties of your inverse graph. The next graph type is squared graph, so pause it and draw it in your notebook. With a squared graph, it starts out really gentle and gets steeper and steeper and steeper as you move to the right. It does not have a consistent slope. So this is not the slope. It once again is the graph constant. Y is whatever's on the y-axis. The x is whatever's on the x-axis. So don't use y and x. It's squared for your x, and that's why it's called a squared graph. Square root graph. Just the opposite. It starts out really steep, gets less steep and less steep and less steep as time goes on. The equation y equals a square root of x. A again is called your graph constant. You're taking the square root of whatever is here, so don't call it x, but call it whatever. And the y again, don't call it y, call it whatever's on the y-axis. Square root graph. Y gets bigger as x gets bigger, but it does so less and less quickly as you move to the right. The final graph is called no relationship. That's the type you're going to get if one variable does not affect the other. One variable does not affect the other. Again, you'll have experimental error, so these points won't be perfectly level. But when you draw your line in, draw it as level as possible so that some are above and some are below. You'll notice there's no x because x is not a factor. X does not affect whatever's on the y-axis. It's called a no relationship graph.